Hello to you, ladies and gentlemen, and here we go again. Please notice that today we're going to be talking about geometric sequences, and a geometric sequence similar to an arithmetic sequence, except that we're going to say that each term is going to be obtained instead of adding to the previous term. Now we are going to multiply the preceding term by a constant. And the common amount by which we multiply each time we call our common ratio. Okay? The common ratio we signify as being r, and you find it by dividing any term by the term that precedes it. Now please take note that on this we need to be careful that it's going to be one number divided by the term preceding it. So for example, let's take a look at this example down here. If I take 5 divided by 1, I get 5. 25 divided by 5, I get 5. 125 divided by 25 gets me 5. And 625 divided by 125 gets me 5. So I can say I have a common ratio of 5. Same sort of thing here. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. Now, I'm going to have people that are going to want to quit really early in this process. You need to make sure you check a long way down the line. You can get 2 in a row that are working that are not going to be a geometric sequence. Please make sure you check multiple levels. So if I take negative 3 divided by 9, well, wait a second, that's going to get me a negative 1/3 when I reduce it. 1 divided by negative 3. That's going to be a negative 1/3. Negative 1/3 divided by 1. Once again, negative 1/3. So we now get this sort of thing. Moving on. Next, let's determine whether or not these are geometric sequences. If I take negative 2 divided by 1, yes, I am going to get negative 2. 4 divided by negative 2, negative 2. 8 divided by 4, yes, that's negative 2. 16 divided by negative 8, yes. Common ratio, negative 2, got it. Okay, and by the way, I should write it as yes. Here I look at these, and I say 5 divided by 3, okay, 5/3. 7 divided by 5, does not match. I know I can stop there. Now, if I'm a little bit clever, I might use the stuff from yesterday and say, ooh, I'm adding 2, adding 2, adding 2, adding 2. That is an arithmetic sequence, but I'm asked, is it a geometric? And my answer is no. Do the same thing here. Give yourself a couple seconds and I'll fill in the answers. And as you can now see, once again, all of them are geometric sequences, and you should be able to come up with the common ratio. Now, like in the other one, we have a formula that we want to use to be able to come up with just the explicit formula for a geometric sequence. So, to find the nth term, once again, the nth term, or a sub n, the nth term of a geometric sequence is always going to be in the form, or can be written in the form, where you have a original value, or the first term, that's a sub 1, times the common ratio raised to the number of the term minus 1. Number of the term minus 1 there. So let's see what we can do about doing an actual problem here. Next, find the explicit formula for the nth term of a geometric sequence whose common ratio is 1/3 and whose first term is 6. Now remember, it was a sub n equals the first term times r to the n minus 1. So how do I fill this in? Just use the values. A sub n equals, my first term is 6, my common ratio is 1/3, and I'm going to raise that to the n minus first power. Now, sometimes it's going to be written with just n there. That doesn't mean that what you've got is wrong. It just means that it's looking a little bit different. So if I have a number times another base raised to the nth power, it's still going to be a geometric sequence. Just have to be a little bit careful and watch for it. And I'm not going to ask you guys to simplify it. So given the following sequence, you are asked now to find the nth term. Well, I'm hoping that people are looking at this and saying, yeah, I can see this. It's going to be a sub n equals, my first term is -3 times what did I do to get from one term to the next? 6 divided by -3. -12 divided by +6. I'm going to get a -2. N minus 1. That's the explicit formula for the nth term. Now you're asked to find the 15th term, so all I need to do is plug in 15 here. -3, -2 times 15 minus 1, which I am hoping is not incredibly difficult. And all we need to do is put that into the calculator. And my calculator is going to say -3 times -2 to the 14th power. Again, your display should look like that. And we now get to an answer of 49,152. Okay, so again, you know what? I made an error there. I did not put parentheses around that, which I need to, because otherwise it will not give me the right answer. There you go. -49,152. Okay, next, let's go in and see what else we've got here to play with. Okay, all right. Next, let's find the explicit formula for the nth term of the sequence, and then we're going to find the 8th term. Well, what have I got going on here? Again, being able to come up with these fairly quickly. A sub nth term, first term is 18, times, what do I get when I take 6 divided by 18? Or 2 divided by 6, 2/3 divided by 2. I'm hoping this is not difficult for people, and you're able to quickly say that's n minus 1. Again, identify, one, what is the first term, and second, what is that common ratio. So now, trying to find the 8th term is pretty easy. And I'll pull up the calculator again and say this time we're looking at 18 times, I'll do the parentheses just out of habit, and I'll use the fraction bar key to help me. And I'm going to raise that to the 7th power because that's 8 minus 1. And I'm looking at 2 divided by 243. Okay, please pause this and see if you can do the next one. Okay, the first term is easy to come up with, but the common ratio is going to be the same thing as, 4/9 divided by 2/3. Now, once again, I know we did this earlier. 4/9 divided by 2/3 is the same thing as 4/9 times 3/2, which when you reduce it, you're going to just get 2/3 there. So my expression, my explicit formula for the a sub nth term is going to be 2/3 times 2/3 to the n minus 1 power. Okay, and then finally, we just pop this thing into the calculator, a sub 8, and for the sake of time, I'm just going to write down the answer for you. Okay, next, moving on, another example. So what happens when we've got trying to find the second and third term? Now, I'm hoping that people are going to approach this kind of similarly to how we were doing the other ones. How do I turn 272 into 36? So what I'll do is I'll do my calculator, and I'm going to say 36 divided by 972, and I'm going to have it do it as a fraction, and it says it's 1/27th. Except I need to break it up into, once again, my 1, 2, 3 pieces. So if I take one, to try and figure out what one of these is, I need to think of this as 1/27th is going to be the same thing as 1 over what to the third power because I'm raising it to the third power. 27 is just the same thing as 3 to the third power. So in fact, we're actually looking at this expression here. So now I'm back to my common ratio. I've got my initial value, which is going to be 972. My common ratio is 1/3. So if I am trying to find this, I can say that 972 divided by 3 is going to get me 324. And then if I multiply that by 1/3, that's the same thing as dividing by 3 again, which is going to get me to, 108. And then I divide by 3 again, and guess what? I still get to my 36 there. So the explicit formula for my geometric expression, or my geometric sequence, needs to be a sub n equals 972 times 1/3 to the n minus 1. Okay, let's take a look at another one. Please copy this down and see what you can do about coming up with this on your own. Go ahead and pause it again, and I will resume shortly. Once again, you can start this very quickly by saying a sub n equals 12 times something. Now, I'm going to approach it a little bit differently than the way I did last time because I think for some of you this might be easier. Remember that the general expression is a sub n equals a sub 1 times r to the n minus 1 power. So I can say if I'm looking at a sub 4, which by the way is this term, that's going to be equal to a sub 1 times r to the, how many times did I multiply it by something? 3 times. And also n minus 1, or 4 minus 1 is 3. So I can actually fill things in here and say a sub 4 is -3/2. A sub 1 is 12, and r to the third. So now I can simplify this and say that, well, wait a second, that's going to be r cubed. And I'm going to go back to my calculator and say, if I take -3/2, and then I divide that by 12, I'm going to get -1/8. And then if I take the cube root of both sides, well, wait a second, that's just going to get me a -1/2. So now I have my r, I've got my a sub 1, so I can finish the expression and say that that is just going to be -1/2 to the n minus 1. Cool there. Next. All right, I'm going to have to switch to the other video because I still have 2 examples. So give it a couple seconds and reload the second one now, part 2.